All right. And I think we are live. Hey, everybody. Welcome to our webinar today, Planning Your Workload Identity Roadmap, Standard Patterns and the Path Ahead. Very happy to be with you on this Wednesday, January 21st. Um, Thanks for joining us. We want to make this as interactive as we can. We do want to hear your questions and answer those questions. Uh, let's go ahead and just test the chat function. If you're listening to me, let us know where you're coming in from around the world, where you're listening from, and we would love to start the conversation that way. It makes this interactive. And while we do that, we'll do some introductions. So I'm Dwayne McDaniel. I am developer advocate here at GitGuardian, and I'm happy to host today as well as lead a part of this conversation. And I am very honored to have two of the best people I have met in this space, and just a pleasure to work with them, Mattias and Matt. But I'll let Mattias, why don't you introduce yourself first so I don't have to
Yeah,
dryly read your bio to everyone.
thanks, Dwayne. Happy to be back. It's luckily not my first time in a GitGuardian webinar. I'm Mattias Gees, Director of Tech here at CyberArk. I joined almost 8 years ago a small startup founded by Matt, who is also on this call. And still, I'm here and around. And for the last 2 years, I've been doing quite a lot in workload identity, more specifically SPIFFE and SPIRE and that open source ecosystem. And I come from like a platform engineering kind of DevOps background, led some big Kubernetes teams, and now on the vendor side.
Oh, awesome. I forgot to say I'm in Chicago, Illinois. So I see somebody else in the chat from Chicago. And Mattias, where are you again?
I'm originally from Belgium, but Matt made me move to London, and I'm still here.
All right. And Matt, I want to do a quick introduction.
Yeah, don't blame everything on me, but yeah, you can blame a lot, to be fair. I'm Matt Barker. Welcome everybody, and thanks Dwayne for having us. I heard in the news this week this is the most depressing week of the year.
Oh,
It's Blue Monday, post New Year, post Christmas, depressing. Everyone's run out of money, so let's try and brighten it up with a talk about workload identity. My name's like I said, Matt. I am VP and global head of workload identity. So I was the co-founder of JetStack, which started off the back of the open sourcing of Kubernetes. We created an open source project that's quite well known for doing certificate lifecycle management in Kubernetes called Sat Manager, which we donated to the CNCF. We were acquired by Venafi, which was acquired by private equity, which was acquired by CyberArk. And now essentially I look at how we adopt and use the open identity standard SPIFFE and apply it to our product set. So that is essentially embodied in a solution called Secure Workload Access, which I look after. And I'm in London, originally from North Manchester, Rochdale, which isn't too far away from a guy in the chat who says he's from Bradford. So I know that part of the world quite well.
well, we have a truly global audience today. So thanks for joining us, everyone from Kenya, India. I think we got everything but Antarctica on this call. So, like I say, it is a dark week outside, but things are getting brighter. And that's by the end of this call. Hopefully, you'll agree about that with identity as well. So, this is what we're going to do over the next 45, 50 minutes or so. And again, we do want to get to your questions. We do want to hear them as we go through. Feel free to always use that question box as we go, and we will make sure we get around to them. And we're going to save some time at the end for a little bit larger of a discussion around those questions. But we're going to talk about the problem of secrets. And you might think, well, hey, we're here for workload identity, but we'll get to that. Then how to move away from those long-lived secrets and the problems that causes. But then other problems that will arise and that we have seen other people hit as they are on that maturity path. And finally, let's build a plan together. And by the time we walk away today, you should know these are the things we can start measuring ourselves against and how we can go from where we're at today to that next level of maturity. So, without any further ado, let me dive into this problem with secrets. Now, before I talk about the secret problem itself, let's actually boil this up. What is a secret generally doing? Well, it is something used by an entity to get access. And when we say entity, uh, most of the time, and we'll get to these numbers later, most of the time we're talking about a non-human actor. What machine identity or workload identity, I personally prefer the term workload identity, is a running piece of software trying to run somewhere to accomplish something. Typically connects to a larger system, typically connects to another service or data source in order to accomplish that thing. There's tons of these. We see these everywhere from agentic agents agentic agents, agentic AI, all the way to your classic database server, anything that's not a human that's running out there needs a way to connect to another system. How we've traditionally done that is we think of, well, this is an entity and it connects to something. Well, how did humans solve this? Well, the long history said we did this with secrets, passwords, and we modified that into a world of API keys and other types of keys and tokens. And if we did it really, really well, we got PKI. But at the end of it, it's just secrets. This long, weird strings that if that matches, we will trust you are you. And a great number of these have ended up being hard coded, being listed out there in plain text. And when you're just starting to prototype, when you're just starting your project, there's a quick way to do it. If you just want it to work and you don't worry about it leaving your machine, this is probably how a lot of people start. But we know that there is a problem with that leaking, that these secrets tend to get out there in plain text in places they're not supposed to be, such as GitHub and public. One of the things we do at GitGuardian, and we've been doing this since 2018, is we look at every new commit that hits GitHub public and uh, scan it for a secret. If there is a secret found, we immediately email the author and say, hey, you've done this in public. Please don't do that. Trying to keep everyone safe. We call it our Good Samaritan program. If you're on this call, there's a probable chance, there is a chance you've got an email from us over the years. And we're doing it in everyone's best interest to keep everything safe out in the world, as safe as we can make it. So we also, as a result of this, know the numbers. We know that last year we saw almost 24 million hard-coded secrets get added to GitHub in public. I don't say last year, I mean 2024, because we release the State of Secret Sprawl report every year. In fact, I'm going to paste that in to our chat right now, so you all have access to this exact report. You don't have to manually type it. But that's a lot of secrets being leaked out there. And this is just what we see in public. We know this problem is actually worse internally. This is the first year, the 2025 report was the first year we released numbers from private repos that we've connected to. We have a lot of users out there in the world that use us for private repos as well, with our free offering, and a lot of our enterprise customers, or all of our enterprise customers, I should say. It's 8 times worse in these private repos. We think that there is a false sense of security people have, that, hey, since this is private, since it's behind our barriers, this is in our perimeter, that, hey, it's not as bad if we put the secret there. But as we'll see a little bit later, it does lead to a lot of problems. And it's not just code that these secrets end up in. It's everything around the code, including all the communication tools and the documentation platforms and the ticketing systems. Also, is where we're finding these plain text secrets. This is not just the developers at this point putting these in here. This is a much wider group of your users and wider parts of your team. And our customers tell us that when they do find these secrets, they're typically higher criticality. They're more often scored as high or critical within the scoring system. One of the worst things about secrets and this acting as these mechanism for authentication and authorization, which really that's what it is. It's a proxy for allowing an entity to do something, is that by default, they exist forever. They just live and live and live. We went back to the valid secrets we found in 2022 and reran our validation detection, or revalidated them with our detection engine and validation engine here in the beginning of 2025, or last year, I guess, the beginning of 2025, and 70% came back as still valid. And the vast majority of secrets we find as valid stay valid over time. Kind of a disturbing trend. That all is getting worse. And the number I talked about earlier, 24 million hard-coded credentials, that was a 25% increase year over year. And it maps very directly with the number of non-human identities we're seeing out there in the world. And this is numbers that we can debate them all day on how exactly we figure these, but we took the numbers from CyberArk, which very happy to have on this call, and said, okay, let's extrapolate that out a little bit more since the time they did it. And the number that we keep hitting out there and people are telling us that they agree with is it's about 100 to 1. Round how you want. But this maps very directly with the number of attacks involving identities, the number of identity-based attacks out there. And there's a lot of these. Now, I've been talking to you for a solid 10 minutes, at you for a solid 10 minutes out there. So let me bring in our team here on the call. Matt, you've done a lot of research out there in the world, and what's your thoughts here?
I'm gonna just follow up with what you've been talking about and ask a very simple question, and that is, do we need secrets at all? Because if you look at all of these breaches, and I agree with everything you've said, massive shout out, by the way, for the work you do with the State of Secrets Sprawl report. I'd say a large number of the customers that I get to speak to or prospects for what we're doing with Workload Identity come to me off the back of realizing they've got an NHI problem. Because they don't know where all their non-human identities are. They don't know who has access to them. They don't really know what they're being used for. And what that leads to is exactly what you've got on this slide here, which is essentially breaches. And so I know the team at Uber really quite well, because they were one of the companies that found themselves in this situation a few years ago. And I actually run a workload identity event at KubeCon a couple of times a year, and we have the head of identity at Uber, Andrew, who actually he doesn't talk specifically about the breach. I think he'd rather leave that to the past. But what he does talk about is the drive of the organization, essentially to try and get that problem under control, because they were essentially compromised by the leaking of a secret that got in the wrong hands. And then that hacker was able to circumvent access controls, get inside the system, and start exfiltrating data. And so he was given a challenge set by the board, which was, can you stop this happening again? And so he looked at all the various different options for that, and he stumbled across a new identity called SPIFFE, which essentially is an open sourcing of an identity standard that was created inside Google. And it's created by the same guy that created Kubernetes. And essentially what it does is it enables you to apply an identity to a workload and enable that workload to talk to other workloads without needing to use secrets at all. So they went on that journey, they implemented that, and they've got to the point now where they don't use secrets inside their business at all. Now that is the holy grail. If you can get there, great. But I think most people on this call will realize we're not going to get rid of secrets overnight. They're everywhere. They're all over the place. It's kind of the standard way that we think about using them. So what I'm seeing from customers, CyberArk customers, as they come to me, they know they have a problem and they know they want to get that under control. And that's where GitGuardian often comes in. The next question is, okay, now we found all our non-human identities. What can we do about them?
And
Yeah. Go ahead,
a
Matt.
big part of like why these NHIs exist is we started using secrets because that's kind of the way that it used to work in the human state, where username and password was quite common, and we used to write it on a post-it note, and then we kind of transposed that system into applications. And where with humans we moved to MFA with like tokens and apps kind of thing to do two-factor authentication, we're still in that single factor with long-lived things in our applications. And because of that big explosion, we end up with like more and more secrets, and like they're really like now the attack factor for a lot of people. And even though like human breaches still occur, it's way more likely now that a machine is being breached because of like this extrapolation of secrets that we're seeing.
Yeah,
it's just a wider attack surface. Like this is like say it's 100 to 1.
Yeah,
there's going to be 100 to 1 ratio of the
and
password.
hackers always go for the easiest route. So
yeah, as we've been saying for a while now, we're seeing the attackers log in, not break in. If you have a key and you're assuming the identity of whatever you stole it from, it's hard to tell if you're actually nefarious in there until you start doing something bad.
Yeah.
So let's, for sake of time, talk about, well, what do we do then? How do we get away from these secrets? And that's where we're very happy to partner with you at CyberArk.
yeah, and that's kind of where we currently like deal with a lot of like those static secrets. They are long-lived credentials, so you might know them as like a username and password to log into a database, an API key that you use to like log into a SaaS service or some internal service. The big thing is they are shareable between workloads, and I compare like these static secrets with a key fob. Like the key fob might be assigned to you as a person, but it's still very easy to give that to your neighbor, and your neighbor uses that same key fob to go through the same door kind of thing. And it's really shareable, and it's not trackable. You can track the key fob. You cannot check the owner of the key fob and really attach it to that entrance kind of thing. And with that, like, risk accumulates over time, because what I've seen in the personal experience from being a platform engineer, those definitely get shared. And because when you start sharing it, each application has their own authorization requirements. Application A needs to talk to applications X and Y, while application B needs to talk to Z. And because they share the same secrets, they inherit all of like these access credentials across the whole space kind of thing. And kind of what we are wanting to go to is an identity that's really tied to the unique workload. It's the same way as like we have our passports. Our passports really identify ourselves, and only we can use our passports. Like, it's very hard to impersonate like somebody's other passport. Like, it's possible, but like it's very hard. And the way that we like to think with that in workloads is through workload identity and through SPIFFE, like this open standard, by having short-lived identities that are getting auto-rotated. And with short-lived, we don't mean days, but we literally mean minutes to hours maximum. They're also very unique to the workload. So like when a workload gets created, the identity gets created. When the workload stops existing, the identity gets destroyed immediately. And we're relying very much on crypto for doing the verification of this, and making sure that like this can be used by target services for authentication and authorization purposes.
Yeah, and just to echo some of what Mattias was talking about, if you won't mind going back for a second, Dwayne, I know that we've used the term non-human identity, workload identity, and secret. It is quite complicated, and a lot of different people like use a lot of these terms interchangeably. I just wanted to pause and say that that when companies say to me that they've got a non-human identity problem, more often than not, they've got a secrets problem, and the industry is essentially trying to get discoverability, or discover and understand the context and the risk of those non-human identities. And at CyberArk, we talk about those non-human identities essentially being encompassed in what we refer to as the 3 Vs. So the volume of them is increasing, the variety of them is increasing, and the velocity of them is increasing. Personally, I don't like to use the term non-human identity, because as my old CEO used to say, a non-human could also be an alien or a chair. He likes to use the term workload and workload identity. So the way that I think about it, at least, is you have machines, and a machine then has a subcategory of physical devices. So think of a phone, a laptop, a server, or you have workloads. And a workload essentially is just a piece of software talking to another piece of software. So it could be a container, a function, a microservice. And essentially that workload is given an identity. And as Mattias just talked about, we think the best way of securing access between those workloads is by giving them an identity, and that identity should be the open standard identity type of SPIFFE. And this is that open identity standard that Mattias referred to, that's now part of the CNCF and was essentially donated by Google around the same time that they donated Kubernetes to the CNCF, which is part of the Linux Foundation.
It's one of the actual problems with secrets that we don't talk about enough, is that it stands in as this proxy, and we've been using it as a proxy for authenticating an identity, an entity of whatever you want, a workload, machine, whatever, human even. But we're saying, okay, we're going to use this to authenticate and also to authorize you to do things. And those are 2 separate concepts. And we have married them together and said, hey, if you have this token, you can get in and do all of this stuff. And that is a hard problem in and of itself. But the mental model of that makes us think in these terms of long-lived credential instead of true authentication and true authorization for an entity, which is a fascinating conversation. All right. So I agree with you. Identities should be the way we do this. But let's face it, we got legacy systems out there and we can't do this everywhere. So how do we know when to do what? And that was that next slide that I jumped to too early.
Go for it.
Yeah.
And go on, Mattias.
Yeah, like that's kind of our ideal would be to apply SPIFFE everywhere. Like Kubernetes clusters, of course, because like that's where SPIFFE actually came out of like the CNCF, but also VMs to like all kind of systems out there. To I hope in the future we can apply them to mainframes and stuff like that. But like we're still a bit far from that one, but like at least apply the identity everywhere. And then some target systems where you want to connect to will be able to understand that SPIFFE identity thanks to its interchangeability with certificate authentication or OIDC and JOT authentication. You can immediately use that SPIFFE identity already to talk to the major cloud providers like AWS, like Azure, like Google Cloud, but also like things like Snowflake and stuff like that. The thing is, like, there is always going to be that database out there, that legacy service that's out there, that's still going to require an API key, a username and password kind of thing. And what we are doing with CyberArk is making it very easy to exchange that unique SPIFFE identity that's attached to your workload, allow you to uniquely authenticate and authorize yourself to our secrets manager, to CyberArk Secrets Manager, and then exchange that for that traditional token so you can connect to that system out there that doesn't understand SPIFFE at all and can start using that. And like, we want to replace like or reduce the amount of like dependency of long-lived secrets, but we also fully accept that they're not going away.
Yep. And we actually have written a guide, and I'm actually pasting that into the chat here. If you're already registered for this, we're not going to force you to go back through another registration to get your hands on this guide that we built with you, or that we built with CyberArk. Mattias, you actually wrote this paper.
Yeah,
So
together with you
please speak on
guys.
exactly what this is.
Yeah, and that's kind of also like currently, for example, when you're in the cloud, you have managed identity there already. Like think about workload identity in Google Cloud, the instance identity documents in AWS, for example. They're really great, and please use them if you are in that cloud storage, because like it's already a really great solution. The thing is, they have a few disadvantages for things, and the first thing is like a lot of our customers we're talking to, they have multi-cloud solutions. Like they're not only on AWS, they are not only on GCP, like they're across many different clouds, which means they need to manage like all of these different identity silos separately and completely differently as well. So there's no standardization on there. Also, on-premise is not going away in the same way that we think secrets is not going away. On-premise is not going away. Like those on-prem VMs also need to get an identity where we currently have no way to give them an identity. And we have then also like many Kubernetes clusters who have their own identity systems, to even CI/CD systems like GitHub Actions and GitLab having their own CI/CD system. What this causes is like when you want to start connecting all of these systems to external data sources like Snowflake and AWS and all of these cloud providers, you really end up with what I would call a federation mesh. Like you have many sources and you need to connect to many targets, and like it's like really like a tangled web of federation that needs to be managed. And what you want to do with standardized identity with SPIFFE is like create that like hub model where they are responsible for, or where SPIFFE is responsible for issuing all of its individual identities, but also manages the federation to all of the external systems and makes it a lot more simple to do authorization in those target systems, because like the way that you then do authorization is one model based on SPIFFE, not based on Kubernetes and CI/CD and coming from GCP and coming from this other cloud provider. It's like one model SPIFFE kind of thing.
And this guide is going to help you make sense of when you could, when you couldn't, where's the right fit. And this is just one image from an entire ebook that we worked on together. So that is a free resource for you out there to help you make sense of this. Because ultimately, we do want to move to a world where we're properly dealing with identities, authentication, and authorization. But we live in the messy reality of the enterprise and legacy and years of building things with secrets. And that presents this entire world where we have a lot of things that we know about, a lot of things we don't know about, and then the accountability problem. Like, do we know what we even have out there? Isn't that right, Matt?
Yeah, I kind of think about the fact that in the past we used to just trust that everything inside the firewall was safe, and then currently we're kind of thinking about using secrets to do that. And obviously, I want to take you to the future and do it purely with a workload identity. But all of this conversation that we've just been having reminds me of when I actually went and spoke to Joe Bader, who actually created SPIFFE, and he was at Google. And he was essentially saying to me that they had the same assumption that all of the workloads inside their firewall were safe. And then the Snowden leaks happened, and they found a sticky note that essentially said or showed that the government, the NSA, was inside the Google network. And at the time, because they trusted that no one could get inside their network, they essentially was sending data around in plain text. And they realized at that point that they were completely and utterly owned. And so he actually talked to me about how he'd considered actually adopting secrets to try and secure workloads when he realized he wanted to solve this problem. But a little bit like how you were saying, Dwayne, like he saw it as like a hack or a proxy for true identity, which he saw coming from essentially PKI, because he was like, every single company has a certificate authority and has PKI. So if you've got that, then how do we use that essentially to go and apply an identity to a workload? So he went from like what was the past, the firewall, to straight to using workload identity by applying a SPIFFE identity to a workload that had been registered and attested, and then use that cryptographic SPIFFE identity with all of the benefits that come with PKI to provide that short-lived identity that that Mattias was talking about. Now, Google had the luxury of doing that because of a relatively consistent environment. Whereas you look at the average enterprise, they have secrets stores everywhere. They have secrets everywhere. They have on-prem environments. They have multi-cloud environments. They have dozens of companies they may have acquired over the years. And so they don't really know where all the secrets are. So the first step in this essentially is just getting a handle on where all these identities are. And at that point, then you can start to think about like what you actually do with those secrets. So how do you start maybe replacing them with a workload identity? Which are the most risky? Which are the workloads which would be best suited to get rid of secrets and start using a workload identity with? But as it says here, your first step ultimately is understanding what you've got and sort of securing what you can't see. And that's what I'm finding with a lot of these working groups inside these enterprises. They're just starting with discovery, but then they very rapidly realize that as soon as they've discovered those non-human identities, they're going to have to do something about them. And that's where they're coming to us to say, okay, like, how do you help us on this journey of like essentially reducing this risk, making my workload identity a bit more consistent, and actually helping us developers to get a bit more productive and stop them from sort of making mistakes and potentially leaking secrets by hard coding them or sharing them in places that they shouldn't be.
Yep. And there is a proper way to store hard-coded credentials. There's a call out a question we got earlier from Kalish out there. I'm hoping to pronounce your name right. Can we store hard-coded secrets in key vaults or in vaults? And the answer to that is absolutely yes. We see that as the positive step from you got it in plain text where it shouldn't be. Well, you should probably put that somewhere where it's encrypted at rest and then programmatically called into the application or the service at runtime, pulled in when needed, and then dumped from memory immediately, depending on how you architecture your applications. Excuse me. But that actually causes another entire class of problem, but one related to what we were just talking about with discoverability and that bottom of the iceberg, the shadow workloads out there, the whole rest of your ecosystem. And what we have seen is the problem. We started calling it vault sprawl in the last couple of years. Is that yes, we want to move to one system and get everything encrypted at rest, pull in only when needed, and per team, that's fairly straightforward to do. Per project, fairly straightforward to do. But again, we're talking about the reality of the enterprise, mergers and acquisitions. What happens when you acquire another company and they have a set of vaults they use? And we've seen multiple vaults per project, multiple vaults per team. How many teams do you have? How many instances do you have? This puts the developer in a bind when they're trying to get their job done, when they're trying to go home to their families and close out those tickets in the sprint. They see a world of like, all right, I have to stop what I'm doing, get out of flow, go figure out which vault I'm pulling from. Is this the right one? Is this counted for? How am I sure this is up to date? Is this going to be rotated? You know what? I'm in a hurry. Let me do what I know works. It's not safe, but I know I can just slap that secret in there. And we think that accounts a hard-coded secret. That accounts for a lot of hard-coded secrets. It's just developers trying to get their jobs done, getting in this point of confusion and saying, we don't know exactly what to do because we have too many vaults. We don't know what's in these vaults. And from a organizational perspective, how much redundancy do you have? How many systems overlap? The larger the organization, the more vaults. How much are you spending trying to solve this problem over and over and over again, reinvent the wheel as you go? And it's no magic bullet. We wish it was, but the reason we think we find 5.1% of repos that clearly have a secret manager. Inside the code, contextually, it calls to a secret manager. 5.1% of those repos still leak secrets. It's just not consistently used. And we think the vault sprawl problem is leading into that, are leaning into that. So
I just to pick up on some of what you were saying there, Dwayne, I feel like obviously having been in the cloud native ecosystem since the beginning, I feel somewhat responsible for helping create this problem, because in a lot of those early Kubernetes deployments, we were working with engineers and Kubernetes folk who just wanted to go really fast. So we get them set up with HashiCorp Vault, and they'd be like, well, should I involve security here? Oh, well, no, I just need to manage my secrets, and I just need a cert. So I'll use Cert Manager, I'll use HashiCorp Vault, I'll stick it in there, and I'll just see if this project succeeds. Obviously Kubernetes and containers became very good for how we thought about building infrastructure to host cloud native applications, and they grew. And over time, this problem got worse and worse and worse. And a large part of what I see these days is a security team realizing the problem they've got. And it's not the developers that own this problem if something goes wrong and the secret gets leaked and they end up getting hacked. It's the security team. And so there's a disconnect here between the security team and the developers, and the Kubernetes engineers have gone and created all these vaults and created this image, which is essentially the chaos of secrets management sprawl.
Yeah, and these are like the questions you should be able to answer about your secrets and your workloads, kind of thing. And that these are exactly the questions we are trying to answer when we are thinking about workload identity. We want to be 100% sure that a workload or an application is as good as it is, and that we can actually verify and attest this like with cryptographic identities then. And then like, because we have like tied cryptographic identities to those workloads, we can even start tracking like workloads communicating to other workloads out there, and really creating that fine-grained audit log. And like, did the human take a secret and use it outside the secrets management spaghetti? Guilty as charged. And that's what we had, for example, at the previous project, like where we're using a secrets manager. But like, for local testing, we needed to gain access to the secrets, and by accident, we committed them to our private Git repo in a GitHub Enterprise. Luckily, we spoke up and we fixed it immediately, but it still happened, and it's so easy to make mistakes. They are not on purpose. These things happen. It's in a lot of cases, it's also like just by mistake, like just quickly doing a git add dot, and like you by accidentally commit all of your secrets without like thinking about it. And then rotation is like the big topic. Coming from indeed that platform engineering background, I've never seen secrets rotation work well, because like there is too many things that needs to be done properly. Like you need to first go to the target system where the secret is coming from, generate a new secret, then store this in the secrets manager, then make sure that the system that's actually using that secret is starting to use that new secret before you can start retiring that old secret. And you need to monitor and watch that whole pipeline. It's just so freaking difficult. And that's why we believe workload identity is the answer on this one, because by default, it's short-lived. And by default, you cannot do it without any with automation in place from day one. So we really solve that fundamental problem, while with like the way that we think about username and passwords and API keys, with automatic rotation, we're trying to kind of fix that in hindsight, which is like, we need that still, because like there is still those systems out there that are going to need that. But like, if we can do it with like rotation from the ground up, built into like all of the technology that we're doing, we should do that, and do that on a strong identity that's cryptographically backed.
Yeah, we think that is a major reason we see long-lived credentials not get rotated, is the complexity of the rotation. And then the real downside of it is, if this breaks, we take down production, and it's going to take us a while to figure out how to get it back up and running. Or we leave it running and cross our fingers and hope there's no breach, that we hope we're not exposed out there. So we had about 10 minutes left before we open it up for general Q&A. So let's talk about solutions here. What do we do from here? Well, we have witnessed teams go through this journey. Now, there's a lot of maturity models out there. There's a lot of ways you can look at this. This is a very simplified worldview that takes into account basically secret management and vault management, and getting toward that world of I realized I have messed this slide up, because this shouldn't say that. That should say, complete workload identity up at the top. Apologies there, everyone. This was my fault.
But do not follow this.
Yeah, you're not to follow this. I'm not going to fix it in real time, but apologies there. It's embarrassing. I tried to fix the slide. Anyway, we see most organizations start with a world of hard-coded credentials, hard-coded secrets. Again, if you're prototyping something, if you're just trying to get it to work on your machine just to POC it, proof of concept, then yeah, of course, that's probably where you're going to start. But then we see a lot of organizations here where they have implemented basic secret management. Their vaults, secrets are in vaults, and they are working toward a world where they can do automatic rotation, but really, in all reality, they're manually rotating, and mostly they're rotating reactively because an incident happened, or we got breached, or something's happened. And then moving to a world with dynamic secrets, with fast rotation, we see a lot of organizations between these worlds, like for one, trying to get to level 2, then level 3. And again, apologize here. It's not hard coded secrets. It is actually a world of true workload identity management, a world where everything is dynamic, where everything is short lived. So apologies there. I feel very embarrassed. I'll stop harping on it though and get to how we at GitGuardian can help get down this road. That big problem is understanding what you even have out there. Now, if you were a single developer and you have one application, it's pretty straightforward. But that's not what we're really talking about here. We're talking about a world where you have a lot of legacy systems out there, a lot of secrets and identities out in the world. So the first thing is find all those secrets, get that visibility into what you have in both places where they're not supposed to be, hard coded out there in plain text in the code itself, the hard coded, like that level 0 going to level 1. Or, hey, we got these in a vault, but we have vault sprawl. What's in these vaults? We have a lot of service providers. Who's providing what? How are these things being used? As you start building your maturity, you can use GitGuardian to go from I don't know where anything is to, hey, we know where everything is. Now we can start working toward getting them consolidated, getting things that aren't in the right places to the right places, making sure that they are in the right places at the right times. And then we can start looking at facts about them. How are they being used? Where are they being accessed? It's things that every company is going to need to deal with from compliance reasons, for internal efficiency reasons. What's your lifecycle management look like around there? How can you even start answering those questions when someone comes to you and says, how are we doing with getting away from traditional secrets, moving toward this world of true workload identity? So I'm not going to do a full demo. Obviously, don't have a lot of time today, and I don't want to anger the demo gods by trying to flip between screens on this. I already messed up once. Don't need to mess up anymore. So I'll just show you some screenshots real quick. Most people know us at GitGuardian as we can scan your sources for hard-coded secrets. 100% true. Not going to show you those screens because we scan everything. Now we have bring your own source. If it's got text, we can make it a source and scan it continually. We'd love to work with you on that with our APIs. But now we can connect into your secret managers, to the vaults themselves, and say, here's a true inventory of what you have in there. And I can start comparing that list. What's not in here? What is in here? And we have provided mechanisms to push to vault to let you get things that aren't in the secret manager into the secret manager. And then what we've added very recently in the last year is our NHI governance solution, where we can start connecting into Kubernetes or look at the specific manifests inside of your machines. This is still forthcoming. Look at your CI/CD pipelines, and now look at the actual identity providers themselves: AWS, Okta, Auth0, Entra, as well as SaaS providers. Not showing those on this list. It didn't cram too much onto a slide, but start looking at not just the secrets, but that world around it. Like, what is our identity inventory? What does exist out in the world? Where do we know it's stored? What policy breaches have occurred? How risky is it? What level of criticality is this publicly leaked key for this engine or open API key? Probably low risk because it's probably invalid, but give you that true map of like, how is this being used? So give you that clarity, so that we had that messy map earlier of like, there's chaos going on. There's so many systems, to give you that clear knowledge that this particular entity, this identity is being used this way inside of our system. And now, who is responsible for this? And give your teams the thing that every IAM team is always going to ask: who owns this? Who's actually responsible for this? And now we're making that clear, and we would love to work with you to refine that and make that work with your internal systems and policies. But ultimately, we want to partner with CyberArk, who we want to be the observability plane. Say, here's everything you have, everything that's not inside of CyberArk, but CyberArk is going to help you go from that chaos of, hey, we have to live in hard-coded secrets. We got vaults. Let's help you get to where you really want to be, which is true identity. Mattias?
Yes. Let's go to the demo, I would say.
All right. Well, yeah, let's jump straight to it.
Yeah. So we have developed a product within CyberArk called Secure Workload Access, and we are with that product SPIFFE native kind of thing. And a common use case we have is an application running on a virtual machine connecting to AWS kind of thing. For example, to put a file in S3, and you can see here like a policy for S3 to be able to write to. It can currently write to everything in S3. Normally, restrict this a bit more. But what we see here is also like the role trust relationship. We connect this trust to our secure workload access, and we are saying this specific workload with this SPIFFE identity, and the audience of AWS can connect to it. And when we go to our virtual machine, where we also are copying our IAM role, we see that we have no static secrets defined in there, but we're actually extending the AWS config with the credential process, which is built into AWS SDKs kind of thing. We're saying we're wanting to assume that role that we have there. We make sure that the audience is correctly. And we're also telling that we need to get our identity from that API socket kind of thing. And the way this looks from an application perspective is I can just retrieve a file from S3. Currently, that file is not there, so hence why I get failed to get object. When I upload that file now and I go back to the S3 bucket in AWS, we can see that that file is now there. And when I go back to my application, I can retrieve this file. The nice thing is this is an application running on a virtual machine. It doesn't run in AWS at all. But for that application, it is as it would be natively running in AWS. Like there is no application code changes needed. It just plugged into the back kind of thing through that helper function, through that credential process. It fetches its workload identity, its SPIFFE identity, and it uses that SPIFFE identity to authenticate to AWS. AWS verifies it thanks to the common trust that it has with our installation of Secure Workload Access. It does this through OIDC, if you're aware of that one. And then based on the policy that's been set in AWS, it's going to authorize that specific SPIFFE identity to assume that role. If I would be even a different SPIFFE identity from the same trust relationship that I have, I would not be able to assume that role thanks to the fine-grained authorization that I have defined in the IAM role bits in there.
Thank you very much, Mattias.
Anything to add, Matt?
No, that was I guess I still continue to be amazed as to what we're doing here. It's so cool. I mean, it's like essentially a unique and universal identity for every single workload that you can use to speak to other workloads securely, consistently across any environment without needing secrets at all. I mean, think about what that would do for developer productivity, consistency, ultimate security. It's really quite revolutionary, and it's been so hard to do in the past, and now we're making it easy. And I can't believe we've gone through 43 minutes of a webinar. We've not even talked about AI or AI agents. The great thing about SPIFFE is that it's becoming the foundational identity for AI agents, because in my world, an AI agent is essentially just a workload. So essentially you give a SPIFFE identity to the AI agent, and you essentially enable it to go off and do its thing and speak to other agents or workloads using the SPIFFE identity as the foundational way of securing access between those. Yes, there's more complexity when it comes to sort of delegating human delegation with that AI agent, and that's where Auth2 comes in and CyberArk Identity and so on. But literally for pure autonomous AI agents that are working within your environment, and a SPIFFE identity will do a hell of a lot to be able to help you enable that use case. And that's what we're finding week on week as we speak to these enterprises that are essentially rolling this out. I just saw. Sorry, go ahead.
Yeah,
is
I
that
was just going to go over the question of secondary because like it's quite like additive to that one. Like one of the question there was like, does CyberArk replace or is it complement to cloud native providers, kind of native identities? We are replacing that native identities, and we become like SPIFFE becomes that unique and universal identity that you use everywhere. So like on AWS, you would also get like SPIFFE identity. On Google Cloud, you would get that SPIFFE identity. And the added advantage is that it like makes your governance a lot simpler because like you have like this one identity that's out there. So the way that you do authorization, for example, becomes the same everywhere. But
Yeah.
also you get like the central registry of all of your identities, and federation is also way more centrally managed. Like I know a lot of people that have like tens, 20s, maybe thousands of AWS accounts because like that's how the organization are being done. If you need to set up federation between all of these AWS accounts, it becomes complex really fast. SPIFFE can help and simplify this because you can have a central root of trust across all of these AWS
Yeah.
accounts.
So just to build on that, obviously we become the identity provider for SPIFFE, so we issue the identities to the workloads, but it's built on top of PKI. And obviously CyberArk was quite smart to buy Venafi because a lot of these big enterprises rely on Venafi to do the certificate lifecycle management around PKI. If you don't use Venafi, you may use, for example, a cloud CA or some other certificate lifecycle manager or some other CA as a service or PKI as a service. Then we'll still be able to support you essentially, ultimately, with the solution, because essentially we just need a PKI to work on, and then once we have that, we can then go and issue the SPIFFE identity and use that foundation. So yeah, it's essentially just to echo what Mattias was saying. CyberArk becomes the identity provider and the root of trust.
And if you're now using those like native identities, don't rip them out from day one, like because that's probably not your biggest problem that you need to face. Like what we see, for example, is quite common. It's like a lot of AWS credentials being sit in a vault because they have lots of applications running an on-prem data center that need to connect to the to like AWS or any of the other cloud providers. That's probably the place you want to start. If you're now using those native identities in AWS and Google Cloud and Azure, please keep using them. They're very good, but like in the long term, that's probably where you should be thinking is switching them over to SPIFFE, but like it's not your probably immediate like thing that you need to think about.
So that's a good place to wrap it up here, and then we'll open it up for some of the questions we got here in the chat and any new questions you want to ask. But we really do believe together, both GitGuardian and CyberArk, that if you can't find it, can't secure it. So find it, secure it, then observe it. Once you observe what state it's in, then you can adjust. Then you can say, hey, this shouldn't be in this state, and you can start remedying things. Our solution, if you want to take a screenshot of this for your own purposes later, this is how we see GitGuardian in the world. Again, we started with the world of secrets. How do we address and find all of these hard-coded credentials out in public within your own systems? Of course, we do some other things as well, like honey tokens, providing decoy credentials. Those honey tokens, deceptive technology. That's what I'm saying. The deceptive technology to help trigger alarm bells even earlier if someone does get into your systems. But along the way, we've realized that, well, if secrets are just a proxy for identity, why aren't we dealing with visibility into identity itself? And that's what we've really got into with NHI governance, looking at how those machine identities were authenticated and authorized, and what state are those things in. So we would love to work with you to find all of these and start observing, no matter where they're stored in AWS, your SaaS providers, things outside of code. We would love to have that conversation with you to give you that true visibility so you can secure them properly and observe what states they're in. Make sure they're going toward the right state. And we firmly do believe that that right state is very much aligned with everything Mattias and Matt have talked about today, with moving to true identity-based systems built on things like SPIFFE.
Yeah, there's a few resources here. We actually have this code in the hands of customers as part of a design partner program. We'll be GAing it slightly a bit later in the year, but if anyone's out there that's interested and would like to try it, please do get in contact with us. Yeah, you can test it as part of the design partner program like very easily. And as Mattias was saying earlier, we've combined the functionality with our secrets manager. So we can actually help you to essentially use a secret where you have to, but then use a SPIFFE identity where you can. And if you look at your workloads as a continuum, you have workloads that will be relatively easy to apply SPIFFE to, and those that are harder, let's start with the easy ones, and slowly but surely replace all those workload identities that you've currently got that might use secrets with SPIFFE identities. I think there's a QR code there for the design partner program. There's a quote there from Joe. I was talking to you about him. He's the founder of Kubernetes, also the creator of SPIFFE, and he's retired now. And then we also have the Solving the Bottom Turtle book, which is an open source book. You can get it for free on the internet. The relevance of turtles is there was a science fiction book that talked about the Earth being carried by a cosmic turtle. And then there was a question, so who carries that turtle? And the answer was, well, it's turtles all the way down. There's turtles upon turtles upon turtles upon turtles. And that essentially refers to what we think of as the secret zero problem. So you put a secret into a secret store, but then you have to have a master key to enter the secret store. So where do you store that? You store it in another secret store, and then another master key, store it in another secret store, in another secret store. And essentially it's secret stores all the way down. So SPIFFE is there to try and help solve that bottom turtle problem, or the bottom, the secret zero problem, or the bottom secrets manager problem.
So do want to jump to questions here, so please feel free to ask. And I see a question from Zach from a little bit ago. Zachary Grunberg, thank you very much. When GitGuardian finds a secret in legacy code base, what does the remediation pattern look like in the CyberArk ecosystem? That's a great question to start with, and I think Mattias, you're better answering the second part of that. Do people find using CyberArk as the central root of trust identity, or should it complement the cloud provider native identities? The reality on the ground is GitGuardian is amazing at finding secrets and now figuring out what identities you even have. As far as secrets and legacy code, that's why we built our push to vault feature. You find a secret, it's not where it's supposed to be, it's not in CyberArk. Well, let's push it over there. You want to talk to us about migration strategies of like, hey, now that we know where all of our secrets are across all of these vaults, and fight that vault sprawl, and we'd like to get them to CyberArk, that's a matter of scripting. That's a matter of leveraging our API and push to vault features and the way we can interact. And that's why we love working with CyberArk is once we get to that point of, look, this is all accounted for and consolidated down, then CyberArk can do what they do amazingly well. And well, that's Mattias, you can answer that other part of the question.
Let me just quickly start here. I just want to get real with people. Obviously, there's a lot of HashiCorp Vault out there, and so you're often probably, Dwayne, finding secrets in HashiCorp Vault. I think obviously CyberArk has a secrets manager, so obviously we'd love for you to use the secrets manager, which used to be called Conjure, which is now called CyberArk Secrets Manager. We understand that it can be quite difficult to think about migrating all of your secrets from HashiCorp Vault into CyberArk Secrets Manager. So what we actually say to a lot of our customers who find these non-human identities and realize they want to do something about it is, well, if you want to leave them there and you just want to get centralized management of them, that's fine. We have a product called Secrets Hub, which actually supports all of the cloud secret stores and then also HashiCorp Vault. So if you really want to leave them there, like, we can do that, and we can centralize the management and the rotation of that using the CyberArk Vault. If you decide that you want to do something a bit more than that, then you can start to essentially move your secrets into CyberArk Secrets Manager, and then you get the additional functionality of what we were talking about with Workload Identity, which is hugely forward-thinking and innovative and new for the industry, because we can essentially bring your workloads into CyberArk Secrets Manager, and we'll give you the option of using a secret or using a workload identity or a SPIFFE identity. And so all of a sudden, we're kind of getting to the point where we can cover all of your requirements, whether it's workload identity or secrets management, or you can leave your secret stores where you are. So we're a very pragmatic organization, and obviously it sounds like a sales pitch. I only joined CyberArk 18 months ago, but genuinely, like, we realize the challenges that enterprise have with all of the messiness of the vault sprawl and the vaults that are there and the reliance on them. So you can keep it there. We'll organize that. We'll help you to manage that. But over time, we would say bring it into CyberArk Secrets Manager, and we'll find better ways of managing and securing access between those workloads by using Workload Identity. So I just want to start that. Yeah, go on, Mattias.
Yeah, and on top of that, like, the data and the secrets that GitGuardian finds are massively useful to make decisions about. It makes you help decisions about where you have like a lot of the same type of credentials. Think about AWS credentials, but also like which credentials are like really critical for your organization, you want to make secure better, these can then help inform in where you should invest in switching to more native identities, like with adoption of SPIFFE kind of thing. And so that you can concentrate your effort on tackling those problems first before you start moving on to like some of the other problem sets that might not have the same impact kind of thing. So like it helps you improve the impact that a solution like secure workload access based upon SPIFFE can have in your organization.
All right. Thanks very much, both of you, because if there was only one true way to deal with this, we would say yes. That's just there's the exact clean path everyone in the world can follow. But as you point out, Matt, there's a lot of ways legacy code needs to be dealt with, and there's a lot of options we have out there. But the one thing true of all, if it's not accounted for inside of secret management, you got to start there. You really have to find out what you have, that true inventory. It's I've said this so many times. It's the first rule of threat modeling is knowing what assets you have. And this is so true across everything you're dealing with. We are wrapping up here. We do have a few minutes left if we do have other questions coming in. But I did want to talk pragmatically, like, where do you go from here? I know someone else asked earlier about literature on how to use a secret manager. So if you that's something I'll point to you all CyberArk. Like, well, you guys build secret managers. How would you what direction would you push that person?
Yeah, I think, Mattias, I'm seeing here questions around storing hard-coded secrets inside a key vault. I'm seeing best practice for CI/CD.
Yeah.
Um,
So of course, like it depends on. So to start using a secrets manager, it's a technological problem and a process problem. Like the process problem is like I need to first get the secret, I then need to store the secret, and I need to retrieve the secret. And depending on your organization, that process might be different per organization. And also based for especially the retrieving of secrets, it's also very much going to be dependent on the platform you are. If you're, for example, on Kubernetes, you have things like external secrets, like CSI drivers, that make it a lot easier for your application to start consuming those secrets from secrets managers. If you're, for example, in an on-prem VM, you might need to do a lot more of work around automation to start consuming them. So like there is not one size fits all. Like it really depends a bit on your org and the platforms you're on. But like a great thing is like all of the secrets managers out there, including CyberArk secrets managers, they have SDK, so you can always build it natively into your application. But there is a lot of helper functions out there that like make it easier to give it as like on a file system that's a tempfs or like an environment variable or something like that. The CI/CD, what I would suggest if you're having CI/CD already, start using the managed identities that the CI/CDs have, like GitLab. They can give you JOT tokens that contain all of the information of like the repo you're running from, even the branch and the commit and the author of the commit even. And you can then start using that OIDC token to start federation with AWS and stuff like that. Of course, in the long term, and I actually have like proof of concept that does this, switch that out for SPIFFE. So like I have like proof of concept that uses that information of like the repo you're in, and then gives you like this SPIFFE identity that's attached to that one after verifying like the OIDC identity behind it. And the reason I'm saying on doing that, especially if you're running from like public GitHub and GitLab, like everybody that's on public GitHub and GitLab gets their token signed from the same key that's managed by GitHub and GitLab. There's nothing wrong with that one. But what I've seen is manage countless misconfigured authorization commands in, for example, an AWS or in a GCP, and by accident giving each repo in GitHub access to your assume role activity instead of like just the specific action that needs to have access to it. So like there's still like misconfigurations that can happen there.
Well, we are out of time, everyone. I want to spend this last few seconds to say thank you for everyone that's joined us today. I hope you've learned something. I know I sure have. I already know when we upload this later to YouTube, By the way, this will be available to everyone that's on this call for replay, and we will make this publicly available as a public webinar on our YouTube channel. I know that your demo is going to be the most replayed section that, when you see those graphs of most replayed part of the video. So I'm looking forward to rewatching it myself.
Yeah, and reach out to me on LinkedIn or somewhere, or even over email, and happy to help and talk to you about SPIFFE. Always nice to geek out.
All right. Thanks, everybody. Thank you, Matt.
Thank you so much for having me. Good luck with secrets and workload identity. Bye, everybody.
Bye-bye.
Bye.